Hi everyone. So this is just a screen recording of what the Desmos activity we did during class today. So if you missed it or you want a refresher, this is great to use. This is for similar figures. So I'm just going to hit join. Okay, so if we look at triangle A to triangle B, I can see right away that the triangle got smaller. So when we get something is smaller, it is called a reduction. When something gets bigger, it's an enlargement. So when I am reducing, I'm either looking at reduction of 4 or reduction of 1/4. Well, in prior lessons when we talked about dilation, we learned that a reduction has to be less than 1, where an enlargement is greater than 1. So a reduction of 1/4 would be our answer for this because it is a fraction. A reduction cannot be bigger than 1. It would just be an enlargement at that point. So when I'm looking at these shapes, these are similar because they are the same shape. They have just gotten bigger or smaller. All the proportions have stayed the same. And that's a key word that we want to remember while we're looking at all this. If I look over here, they are not proportional. I have some really skinny arrows. This one is been elongated. The sides have not been kept the same. Just like if you zoom in on a picture, think of it that way. If you take a picture and you zoom in on yourself, your face still stays proportional. Your eyes are still the same to your nose, to your mouth, to your ears. If you were to elongate it or make it fatter, then everything would look funny. So that's what we're looking at. Similar figures are like when you zoom in or out on a picture. So if I look at this, I have triangle ABC and triangle DEF. Well, I'm missing these sides over here. So what we're going to do is we're going to set up a proportion of the missing side to figure out how I can solve for it. So I'm going to label this triangle 1, and this is going to be triangle 2. Okay, so whenever I set up a proportion, I want to keep things the same in the same setup. So I'm going to have, this is triangle 1 over triangle 2. Okay, so whichever way you labeled it, you just have to stay consistent. So with triangle 1, my first side is going to be 10. Well, the side that corresponds with that on the other triangle is 20. And I'm going to put an equal sign and we're going to set up a proportion. So I'm going to change my color here. Well, triangle 1, the other side I have is 12. And over here is X. And I've successfully set up a proportion on how to figure out how to find the missing side. Now, we're not going to solve this one just yet. I just wanted to show you how to set it up, and we can use our scale factor. When we solve for this, we'll get a number here, which will be that missing side. The other way you can do this is if I look at 10 and 20, well, that's one that can pretty easily come to mind as multiplying by 2. So if I multiplied by 2 here, that means I can multiply by 2 on the 12, and I would have gotten 24. So that when we are solving these proportions, we're finding the new side. We're not necessarily finding the scale factor, but we can figure that out as well. And sometimes they will tell us what the scale factor is. All right, so I'm going to hit next. All right, so with this one, we've been told that they are similar and they've made a proportion for us. So we're going to take a look at how to actually solve a proportion. So what we do is we cross multiply and divide. So cross multiply and then divide. So how I'm going to do that? Well, what we're going to do is we're going to make 2 x's on the diagonal. I have one and I have the other. So it literally looks like a cross, like an X. We've cross multiplied. Done. So now we need to write out what this is going to look like as an equation. So I'm going to have 12x in my purple because I can't multiply that because that's just a variable. In my orange, I have 4 times 9. I can't do anything with 12x yet, so I'm just going to keep it the same. my 4 times 9 equals 36. From here, I can divide by 12. 36 divided by 12, well, x equals 3. So for whatever this is, whether it's a triangle, a rectangle, whatever kind of shape, the missing side that we were looking for was 3. We're going to practice a few more. So this one, again, I'm going to cross multiply and divide. So I'm going to make my x here with my markers. I've made my x. So I like to always do the one that has the x in it first. So that would be my blue. So I'm going to have 21x equals 84 times 2. So I can't do anything with 21x, but I can do something with 84 times 2. And 84 times 2 is 168. And I'm going to leave this 21x over here. I can then divide by 21, and my missing side would have been 8. All right, let's look at this one. So this time they've given us a shape. They haven't given us the proportion. So remember, I always want to label, in this case, it's just a shape. So we don't have triangle, we don't have square, we don't have rectangle. So I'm going to label this one and this 2. So remember, I always want to do shape 1 over shape 2, just to keep things consistent. So in this case, this side here, 4, will match with x. So I will have 4 over x. 10 will match up with 70. So I have equals 10 over 70. So now the next thing I have to do, cross multiply and divide. So we need to make our x. So I'm going to use 4 and 70 and x and 10. So remember, I always like to start with my x first. So I'm going to have 10x equals, well, the other number we have here is 4 and 70. So 4 times 70. I can't do anything with the 10x, so that's going to stay. So I have 10x equals 4 times 70 is 280. And if you want to do that in your head, you could say, oh, well, 4 times 7 is 28. I just tack on that extra 0. All right, I can then divide by 10, divide by 10. I can get rid of these zeros nice and neatly, and I have 28 would be my final answer. So this missing side right here is 28. All right, this one. Again, I want to label this rectangle 1, rectangle 2. I always want rectangle 1 over rectangle 2. If I flip-flop one of them, it's going to give me the wrong answer, and we don't want that. We always want to stay consistent. So 4 is going to go with x, and 6 is going to go with 18. This was supposed to be an x. I'm sorry, guys. Hold on. I don't know why I wrote an 8 there. My fault. This is supposed to be an x. Okay. That's better. All right, so now I can cross multiply and divide. So I need to set up my crisscross here. I'm going to set up my x. All right, so I have 6x equals, well, 4 times 18. All right, which will be 72. I can then divide by 6. I can divide by 6. And x will equal 12. So this missing side right here is 12. All right, so now we have some trapezoids, and we are going to take a look at how to find the missing side for this one. So remember, I want to label 1, number 2. So I'm going to start off with this side with the x, which corresponds with this side with the 30. So x over 30 equals 16 and 24 would correspond. Remember, I always want 1 over 2. So 16 over 24. So now it's time to make our crisscross. So I'm going to do x and 24 and 16 and 30. So 24 times x is just 24x. I can't do anything with that yet because that's that variable. Then I'm going to do 16 times 30. So 16 times 30, which is 480. I can then divide by 24. Divide by 24, x equals 20. So this missing side right here would have been 20. All right, so let's look at this one. Now, this is where it gets a little funny because now I have some angled measurements and stuff in there, but they've kind of rotated a little bit. So what I need to be careful of is that my corresponding sides match every single time. So the fact that I have 40 degrees in this upper corner, that's great. This is 60 and this is 80. Well, because we've been told that they've been similar because it just says find the missing side, this is 80 here. Oop, that's not a 0. There we go. And this is 60 here. So, which is good because that means when I find my corresponding sides, this 10 is going to match up with this empty side, which we're going to label as x. Because the 40 and the 60 are here, the 40 and 60 are here. So good. So my purple side, this is going to be figure 1, figure 2. So 10 over x. And it doesn't matter what you pick as long as you pick the same corresponding side. So in this case, I'm going to pick 6, and that corresponds with 3. You could have picked 8 and 4, and it still would get you the same answer. So we're going to set up our cross multiplication. So I have 6x equals 10 times 3, which is 30. Divide by 6, x equals 5. So this missing side over here would have been 5. All right, last one. So now I have a shape within a shape. So we just have to be careful with what we're using here. So this blue rectangle, I'm going to label as rectangle 1. And this bigger rectangle around it is going to be rectangle 2. Remember, I always want 1 over 2. So I'm going to use side 12 first, and that matches with 26. And then my other one, 5, you can't really see that because it's blue, so hold on. 5 matches with x. So we want to set up our crisscross. So I have 12x equals 5 times 26. And 5 times 26 is 130. So I have 12x equals 130. I can divide by 12, divide by 12. And in this case, I do get a decimal. 10, 8, 3, and the 3 is repeating. I threw that in there just to make sure that you did these right because all the other ones that we did were whole numbers. So this one was a little bit of a trick. Okay, so that is it for similar figures.